Now let's go to the next part of the SPT Metalog system, which is basically if the log of Q of your quantile parameters minus a lower bound, and your lower bound can be anything that you specify, if the log of your quantile parameters is Metalog distributed, you've got the log Metalog or the semi-bounded Metalog. And in the same way, it has all of these similar properties, which is specifically that these A coefficients are closed term functions of your quantile parameters, Q alpha, the median, Q1 minus alpha, and now the lower bound. And it has a similar closed form feasibility condition, which is pretty similar to the one I showed you for the bounded Metalog. But anyway, there's the equation for it. There's a whole explanation of this in my 2016 paper, so you can read about it further if you want. But for now, the key feature to observe is we still have all the shape flexibility and even more. Plus we have the closed form parameterization. Since we have an extra parameter here, which is the lower bound, now we have a distribution with two shape parameters rather than one. So it corresponds to an area on this chart. And particularly, this blue line here is the upper limit of the semi-bounded Metalog. Okay, the semi-bounded three-term Metalog. And down here is the lower limit of the semi-bounded three-term Metalog. So it includes the log logistic on one end. It includes all the three-term Metalogs out to here and kind of goes down this way. So it can do a very good job of approximating the Weibull over a reasonable range of Weibulls as well. But if you really wanted to get an exact approximation of the Weibull, then you'd use more like 5, 7, or 9 terms, something like that. But anyway, so it corresponds to this much wider range of shapes than even the three-term bounded Metalog. And then if you go to 4 terms, the 4-term semi-bounded Metalog, which we're not going to discuss today, but it has this entire range of shape flexibility here, and then it kind of goes down further as a result. All right, let's do the one more piece of the Metalog system here, of the SPT Metalog system, and that additional piece is now for bounded distributions. And now here you specify a lower bound and an upper bound. These can be anything you want. And you're using the transform, the logit transform. And if this transform of your quantile parameters is Metalog distributed, then you get the logit Metalog distribution. And once again, it's a very flexible bounded distribution, far more flexible, it turns out, than the beta distribution. And again, it is a closed form function of your quantile parameters. And the feasibility, again, is a closed form function of these quantile parameters. So it's a completely closed form system, and this and you have your choice for whatever makes sense for your application as to whether you're going to use a bounded, semi-bounded, or an unbounded SPT Metalog distribution. Where does it fall on this chart? Well, here's the upper limit for all distributions, and the 2, 3, and 4 term bounded Metalog distributions, the logit Metalogs, all lie exactly along this line. So nothing can be up here, and the 2, 3, 4 term logit Metalogs cover all of this area. The 3 term, which is the one we're just talking about here, bounded Metalog, its lower limit is down here. So if you want a bounded distribution with the Metalog system, you can have any bounded distribution anywhere in this really massive area on this chart that corresponds to these various skewness and kurtosis combinations. In contrast to the Pearson system, the beta distribution, if you want a bounded distribution, your only choice in the Pearson system is the beta, and it only covers this small area here.